So for those of you that haven't heard the news, haven't picked up a newspaper since the 90s, let me be the one to inform you that geometry nodes is being updated, redesigned to fields. Maybe you heard about this. What the fuck are fields is probably the first question you have in your mind. Long story short, geometry nodes is being redesigned to be more like the shader editor, which is great because a lot of us have a lot of experience in that kind of node network system without attributes and all this fucking nonsense. And some of the things that have been added, for example, is instead of like a position attribute that you then mess around with more attribute nodes and it's just nonsense, now we have a position node. Similarly, instead of like a normal attribute and all this, now we have a normal node, and all of this works in the way that you would expect. You do some vector math operations and it's great, except for the fact that I've recorded many geometry nodes tutorials at this point, and every single one that I've made is now useless. So yay, I'm thinking let's maybe just talk about what this redesign looks like and how to, work in this new system, and then maybe I'll take a break from geometry node tutorials so that I don't have to go through the suffering of remaking stuff again and again and again. So for this video, I think a good demo would be, let's try to make this like wobbling plane thing that's moving up and down. It's made with geometry nodes. It's not that interesting, but it will show you the differences between how this thing used to be made and how it is currently made. So first of all, how would you make this plane in the old geometry nodes? So here's the result that we're going for. Long story short, it's a bunch of geometry nodes, and we're going to talk about why this is the worst way to possibly make it. And then I just applied a wireframe modifier on top. So I'm just going to hide that. This is the geometry nodes result. So you can see this node network going from left to right is everything you need to do to get this result, and it's not very readable. And quite frankly, I have no idea what's going on. So you got to go step by step by step. We start off with a grid. It's just a plane with a lot of geometry. I took the position attribute, where is each point, and I separated it into three components, x, y, and z, each their own attributes. Then for the x component, I increased the domain by 10, or it could have been any number, and wrote that to a new attribute. I then added a driver number to offset this over time, since we're eventually going to take a sine function. I then did the same thing for the y, so it's, same thing going on here. I then took the sine of x, I took the sine of y, I added these two together, so we have two waves contributing to the height. I scaled the height by some number so that it wouldn't be so intense. I added that to the z, and then I rewrote all of that into the original position, making sure that we're not using the the temporary attributes we used just to get this result, which works, and it's procedural, and we can mess with it, and then we can apply the wireframe modifier. But I think you're understanding the point. This technically works and it makes a lot of sense with attributes, but you cannot get from left to right understanding somebody else's node network, and even making this thing gets very confusing. So let's remake this using the new node fields. Okay, I've loaded up a fresh Blender project. Make sure you download one of the newer builds of Blender so that you have the fields thing. So I'm using 3.0 alpha. Before we start, very, very important, you need to go to edit. You need to go to preferences. You need to, it's not an option. Go to experimental, and then in the geometry node fields, make sure you enable that. If you don't do this, geometry nodes is going to work the way it used to with attributes, and it's smelly, it's stinky, I want to flush it down. Make sure geometry node fields is enabled, and now we can get started. So let's just remake the effect using the new logic system for, simple effect, but whatever. So I'm opening up a new window. I'm making this a geometry node editor, same way that you'd make it, otherwise. For this cube, I'm going to make a node group. I'm going to delete this input, and we're going to basically follow the same logic of making a plane that we distort on x and y and add that to the z using fields. So first of all, let's add in a grid, same as last time. All of this works exactly the same way. But the next step in this process would be we took the position and separated that attribute into x, y, and z. If you look at the attributes, you're going to see that there really isn't much here. There used to be 30 fucking nodes, attribute math, attribute whatever. There's no attribute separate. We are no longer using that. So what we want to do is we want to separate the position into x, y, z components. How do we do that now? Well, like I said, fields makes everything no longer an attribute generally. So if you want position, you literally type in position, and you get a nice little position node that updates to where you are in the geometry, and that will make sense in a second. So here we have the position of every single point on this plane stored, if you want to think about it that way. To separate it, you do the same thing you would in the shader editor. So I'm going to separate x, y, z. these nodes should be familiar, and we have these nice purple sockets back. Everything is the way you would expect. So what I want to do is I want to make a sine wave going up and down on the X, up and down on the Y, and just add that to the Z channel, long story short. So let's do that with math. So basically the key difference here is, even though the idea is the same here, the key difference is now we're like operating on like very understandable things that we can trace back, and we're no longer messing with attributes doing one operation at a time, and it takes forever. So position, I've separated it. Now we have the sine of X, the sine of Y. So you want to imagine that we now have two waves on each axis. I'm just going to add those together, and then I just want to add that to the Z channel, since the Z, the up and down, is what should be waving. So how do we combine and do all of that? Well, instead of separate XYZ, you combine XYZ. So this is our new Z channel. We've just taken, these two waves and added them. So that's the Z. For the X and Y, I don't want to manipulate anything, so I'm just bringing back the original. And then the question is, how do we like take this new like position coordinates that we've made? We've basically made a position coordinate transformation. How do we take this and apply it to the mesh? Well, I think it's a new node. There's a new node for this. So you type in position, you're like, I don't know what I want. Position set, that's kind of what I want. So you take the geometry, you send it through here, and then you're saying, where do I want the position of each vertex to be? Well, right now the mesh disappears because every single vertex is being mapped to 0, 0, 0, which means that it's all converging on the origin. Well, I'm just going to set it to this new one, which isn't going to be exactly what we want yet. We'll fix that, but you can see it has a distorted kind of thing. We took the plane, and now we're moving this up and down on the Z channel. So if we look at this from the top down, should look the same because we didn't manipulate X or Y. So now all we need to do is kind of like do the same thing we did with attributes. So the sine wave should be pulsing up and down and have a bigger domain to work with. Before we even get to these X and Ys and all this, and by the way, just to clean things up, I'm going to take these X and Ys that we're just transferring over and just reroute them so they're out of the way. So again, very easy to understand. What I'm going to do is I'm just going to take the X channel before we do a sine function and just multiply it. And you can see the bigger the number, the more waves we get, because there's more periods for it to oscillate through. But I'm just going to multiply it by 10 on each channel. So now you can see we have kind of like a corrugated sheet. By the way, if we want the Z channel to be not as intense, let's just multiply this Z channel thing that we're, mapping, and just multiply it by a smaller number. Makes sense. We want to have this thing animate, so I'm just going to do the same thing I did last time. And by the way, every single operation I did here could have been done with vector math, to be honest, but I separated X, Y just to prove a point. So either way, I'm going to add something to the X and Y channels. You can see this is kind of like an offset slider. And all we need to do is say, I want to animate this thing relative to a driver. So I'm going to do hash frame divided by 15. That's going to give us the frame number we're currently on, but 15 times slower. So it's not super fast. And I'm just going to add that to both channels. And you can see now we have the same result. We can still control the height. And all of it has the same amount of procedural control as before. But let me ask you, which of these is more readable? The attribute one, where you have to literally keep attributes in your mind, tracking them. You have X temporary, Y temporary, or does it make more sense to take position, separate it into components, do something on X, do something on Y, recombine them, and set it to the new position? I don't know, just a thought. And so at this point, what we do is we just add in a wireframe modifier after the fact, and that's just because we don't have wireframe yet in even in the geometry node fields. That hasn't been added, but let me add another source of motion just to make this thing a bit more complicated, but also to prove a point about this node. So I'm going to have this wave, and then I want it also bobbing up and down. In other words, we need to take this and set it to a new position. That's the same as before, but now the Z channel is going up and down. And we could do it back here, but I just want to do it as another step so it's more readable. So let's do that. I'm going to set position again. That's going to make everything invisible. Why? Because every vertex that is now a wave has been, again, remapped to 0 at the end here. Well, what I want to do is take these positions. So you could either reuse the node, it turns out, or you could just add in another just to have it closer by. But you could use either. That's important. So how would we have this thing bob up and down? Well, again, same idea as before. You take your position. I'm going to separate it by XYZ because we only want to manipulate the Z channel. And then same as before, pretty much, I'm just going to do a sine manipulation. So this thing is going up and down relative to some oscillation, right? So I'm going to take a sine. We want it to evolve over time. So I'm going to add by, like, I don't know, again, a driver. And what we want to do is update this to the new coordinates. So we're going to take this position, which again is after this happens. So you have to imagine that these position nodes are storing different information in some sense, because this one, and again, you could reuse the same one, which is why it's a bit confusing, but it's also very convenient. Like this means different things in different contexts, but just to keep it simple, let's have two position nodes. This one is in some sense representing our original grid that we then turn into this corrugated wave. Now this is already stored in here. And what we want to do is now have this thing go up and down. So by the way, it's not X channel, it's supposed to be Z channel. So we have this go up and down. We then need to, recombine everything in a way that makes sense. So I'm just going to combine X, Y, Z. We only want this to manipulate the Z channel. And then you could, replug in X and Y. What I would recommend, but we do need to add it. So what I would recommend is we're just going to do vector math. So we're going to do this position that we already have, the corrugated sheet, and then we are going to add this Z channel and set that to the new position, which you can see gives us the same thing, but now it's going up and down and it's crazy. So to make it less intense, let's just take this and scale this kind of transformation vector by like 0.1. So now it's just kind of barely hovering, okay? So again, how do we read this node network? We had a grid. We then took this position. We did the X, Y sine things and added them for the Z channel, set that as the position. And now we wanted it to bob up and down. So we took the position. Again, now it's the corrugated sheet. I took the Z channel, made it go up and down with a sine wave, and then added that over to the position and reset it, okay? So I've separated this into two very readable operations. Now, again, the key point here is that with the way this fields works is, yes, it's more readable, but you can actually reuse the same position node. So you can see I've now reduced this to a single position node and everything still works because this node stores an idea. It doesn't store literally the positions at the beginning. This represents different contexts before this set position and before this set position. So really try to get that in your head if possible. Get that through your fucking thick skull. It's important. This is only going to send information relative to how deep on this geometry chain we are. But again, you do all this, you apply the wireframe modifier. At some point, we're actually just going to have a wireframe modifier in geometry nodes, I hope. So if it was the case, we do this transformation, and then right here, we'd add in like a mesh and then wireframe, and then we wouldn't have to do it like that. But either way, you can see that this is an entirely different way of working. It's much more similar to shader editor, and the only difference is we have these green nodes every once in a while that are basically symbolizing the steps along the way. But the logic, all these red and blue nodes and purple are, the same as before. So that should hopefully make things a bit simpler. So there you go. That's geometry nodes fields in a nutshell. I'm going to wait a bit longer before I make some like tutorials, about it until some nodes have been added. And I'm sure that they're not going back to attributes or doing something new in general, but there you go. So we're at the end of the tutorial. And at times like these, I like to like shove Patreon down your throat so hard, but you made it to the end of the tutorial. You can click off. But Patreon, why would you want to join? And also thank you to the people who have joined. Patreon is a place where you can get blend files that I upload all the time for all my projects. Over the last 2 years, there have been probably hundreds of blend files you can download. Also, early access to tutorials. You could have seen this tutorial a day or two early because I let patrons see it first, so that's early access. Also, exclusive tutorials that are only posted for patrons. So those are on neither this channel or the CG Matter channel. All these perks, plus Discord, plus all these perks exist for patrons. I want to say thank you to all 700 to 800, I can't remember how many, active patrons. And for people that are thinking about signing on, whether it is for those benefits or just supporting these tutorials, much appreciated. Link in the description. You know the drill. Hopefully I made it understandable, this whole fields thing. See ya.